All right, everyone, welcome to KubeCon. Thank you so much for picking our speech today. We're super excited to bring to you from bespoke to bulletproof, SPIFFE SVIDs for ESO for Enterprise Zero Trust. And I'm Ivy Alkhaz, and this is...
I'm nervous, but my name is May Large.
And we're going to bring you an awesome speech and hopefully teach you guys a bunch of good stuff today. So a little bit about us. One, we like to have fun, as you can see. But I'm a lead software engineer at State Farm, and I was actually a full stack application engineer for a long time before I switched to platform engineering. So last 2 years I've done platform engineering, and this is actually my second KubeCon. So Kubernetes, all that was new, including SPIFFE and SPIRE. So I actually started learning SPIFFE and SPIRE in the last 6 months, and I really am one of the examples how you can go zero to hero real quick.
I'm still May Large. I am currently a platform engineer at State Farm. And my introduction to SPIFFE SVIDs was really from my prior job as selling software solutions, focusing on secure software supply chains with Tecton chains. So that was really my introduction to concepts like workload attestation, non-falsifiable provenance. Like, what's that even? And now it has come full circle, because now Ivy and I are part of a team responsible for our SPIRE footprint across our cluster fleet. So it's pretty cool. It's a full circle now.
Yeah. So let's get started. First off, show of hands, who has used SPIRE in this room? Oh, wow, good portion. I love it. I love it. So this is a bit of an intermediate talk today. So we're going to get into a lot of detail, but I still think it's valuable if you're just starting on your journey or if you're partway through and all of that. So with our journey, just to cover why we use SPIRE, we all want to get rid of static secrets, right? And then why not use the open source CNCF, tried, tested, zero trust solution? So that's the quick why we're using SPIRE. But what we really wanted to address today is how we started with an out-of-the-box implementation, our bespoke implementation, and realized that we were going to have scaling issues with that. As overall adoption was about to hit scale, we thought, we need something highly available and highly scalable, which led us to exploration and implementation of our nestedSpire solution. So to kind of show off the key components of our original implementation, as you can see. So first off, you can see across our clusters, it's really the typical Kubernetes out-of-the-box SPIRE deployment. You have your agent, your CSI driver, things like that. But also you can see every cluster is kind of applied evenly, and that's because of Argo CD. However, we had to maintain all of those manifest and YAMLs across all those clusters. So then one thing to note is we use AWS for this implementation. So the private certificate authority, our root CA, is maintained by our information security. We also use key management store for our implementation. And then two parts that I want to point out that are actually going to be different as we get to our nestedSpire is we used out-of-the-box SQLite, but the problem with that is if you wipe out the storage, all of the mounted data is disassociated. We didn't really want that. That's not the greatest way to do that. And then another part that we wanted to point out was our SPIRE OIDC discovery service. So we exposed it using HA proxy internally. And the problem with our implementation was, as you can see with all of these different boxes, that would mean we have a lot of OIDC endpoints. And I saw the endpoint file and I'm like, this is a lot of endpoints for our consumers to have to factor in. And we didn't want that consumer experience. So we were like, okay, we probably should get rid and improve that. So to talk about how we improved.
Time for Nested. Ivy and I are part of, it's a team of 7 platform engineers, including us. We are responsible for our cluster fleet in AWS, primarily in 2 regions. The first thing we had to determine to realize this topology is to elect or name the mom, the root SPIRE server. And since we already had a management cluster where we hosted a lot of our apps that we're responsible for cross-cutting concerns, it was a natural fit to be the mom, the root SPIRE server. To describe the rest of our cluster fleet, we're really talking 10 clusters, 1 small, a handful of medium, the rest are really large. Multiply that by 2 because we're in 2 regions, and then double that again because we have test and prod. So just to give you an idea of what we mean by our cluster fleet that we're responsible for. So let's first dive into the child cluster. Each of these business area specific cluster became a child server. You still get the same combo. the agent and the server. The difference is, though, and let's just get this out of the way. Across the board, you see SQLite. Ivy hinted on it quite a bit. We replaced that with a proper database, RDS Postgres, across the board. You also see an upstream agent, of course, with the CSI to make consumption and mounting the volume a little easier with the Unix domain socket. So that upstream agent's what's taking care of connecting to mom. I've been calling it mom, shorter for root SPIRE server. Last but not the least is the removal of the OIDC discovery service compared to the bespoke. That responsibility has been taken on by mom solely. So let's move to the left side of this diagram. At the very top is still PCA. The first thing we had to work through with InfoSec, hello InfoSec friends, is to change the pathline to be 2. So the intermediate CA, right, from the root SPIRE server is level 1, and then each of the child clusters are independent in themselves. They manage their own intermediate CA. So there's some independence in each of these child clusters. They're not as needy back up to mom. You notice also on the root server, on mom, there are now 3 servers. Of course, we have the root server connected to PCA for our root CA. We have the internal server for our local workload attestation needs. Because like I said, we have apps local in the management cluster that need attestations, need SVIDs for other connections. Last but not the least is what makes this the mom is the external root SPIRE server. It is what has to be exposed via an ingress HA proxy such that these child clusters are able to declare that their upstream is another SPIRE server, AKA the mom. So you get the topology, right? Child servers up to mom, mom to root PCA. I'm going to take you back up to the root server because I mentioned mom took on the responsibility of the OIDC discovery service. That's now gone, and it's been replaced by the AWS S3 bundle publisher plugin, a mouthful. It's how we're sending the keys to S3, and no different than any static content that you have to expose, we use CloudFront to expose our public endpoint, our public key set. I think I covered everything. This is a test. How many icons are in here? No. We don't expect you guys to. This is just another open source goodness. Phil Merle, cube diagrams. It's a way to generate diagrams if you're lazy like me, but off of your true running resources in both your root server and your child server. Great for troubleshooting, especially because we're not all as up to speed with our SPIRE footprint. And we do support rotation. And when you're this gives you an idea on how these pieces are connected. If you haven't had a chance, check it out, cube diagrams.
So let's talk about our nestedSpire implementation. What are our major learnings? What can all of you take away today and take home and say, I can implement that and do that for my implementation? So a big one is the hard and Helm chart. This was not around when we did our bespoke implementation, so we couldn't take advantage of it, but it is now. And this is tried, tested, true amongst many different companies, and so highly suggest taking a use. And May's going to talk in more in detail about it. And then another one is effectively leveraging the community support. The community has been invaluable for us implementing this between GitHub issues, Slack, things getting solved overnight. It's been absolutely amazing and made us have an easier time implementing SPIRE. So we'll kind of show different examples of that as we go on. And then another one is the external secret operators for cross-account communication. We're going to kind of show how we securely manage the secrets cross-cluster. And then how did we roll out across our clusters and get no consumer interruption? And what did we learn from rolling out to all our clusters? And then finally, consumption. How did all the users use it?
Time for the how. How did we do it? Bespoke to nested. First decision point is to consume the SPIFFE hardened Helm chart. It's called hardened Helm chart for a reason. We understood that it's a community coming together through adoption, through testing, through contributing back. Not to mention, Several large organizations that have had tremendous success in their SPIRE journey, and those are getting baked and contributed back to SPIRE down to the hardened Helm chart that we now consume. That decision alone to apply the Helm chart, which is, you feed it values file, of course, it's a wall of YAML. That decision alone has positioned us to consume the latest SPIRE changes that trickles down to the chart on a monthly cadence, because that's been the release cycle. We started with MOM, getting the management cluster to be the root SPIRE server. Was it easy? Did it just work? No, of course not. Part of it is my fault, because I was trying to marry up a lot of our customizations from our bespoke YAMLs. Yes, Argo realizes it. But to try to marry that up with the values file that we're feeding to the hardened Helm chart, I'm gonna cry, no. That we're feeding to the chart, it didn't work. It caused delays. So we sought out the community through Slack, and we're here to repeat the themes. If you're just starting out, top 3. Number 1, of course, use the chart. Number 2, start with the sensible defaults that come with the chart. Those assumptions, like I said, are sensible defaults, and the hardened chart already has day 2 factored in. In fact, what we had to figure out is how to not drain a whole lot of metrics, because again, day 2 is already factored in, and Dynatrace didn't support some of the metrics that are being emitted by SPIRE and SPIRE agent. Third, and key point, in hardened Helm chart Git repo, there is a run test shell script, depending on the flavor of the chart that you're using. That's going to give you a step-by-step, sequential set of steps on what it takes to get a handful of clusters realized into your target SPIRE topology. We're using nested full, there's nested security, there's federation. It is a great jumpstart. Take advantage of it. Beyond Slack conversations, we're gonna use the stage a little bit more. Beyond Slack conversations, there are discussions that would have to continue on and we need the community to weigh in, and especially the maintainers. Those get redirected to GitHub issues, and this is just a handful of the GitHub issues that we've been a part of, or we've initiated. I'm just gonna pick out the second one. Yeah. That was initially a feature request that turned into just a documentation issue, because upon testing, the AWS Go SDK already does that resolution. You either have your static secrets, which is a no-no, but URSA is already supported, so it just became a documentation issue. On the how did we configure the nestedSpire chart? TLDR for this, remember the topology. And I mentioned use the sensible defaults. Those connection points are really all that we had to provide. The rest are defaults. Now to bring this to light even more, here we go. Let's see how this renders. Can you guys see that okay? This is our Argo app on how we set up MOM. MOM needs to know about the child clusters, and she does that via the kubeconfigs. There's a line there for kubeconfigs where we define the unique cluster IDs with the key value of kubeconfig base 64 with an empty string. On the right-hand side, I'm going to point out that this is a multi-source Argo app. So we first feed it values, right? We kubeconfig set to empty string. There's a subsequent source, just reading from our Git repo, and one of the manifests in there is our powerful external secret. That's now going to lead us into the ESO part of this talk. It's that external secret that then brings in the hydrated kubeconfig values. And just for completeness, the last section there, this is like an overlay action, right? You have values, kubeconfig's empty string, you overlay that with an external secret, now with the hydrated values. So last bit there, no different than what you're gonna need to do with any other Argo operator, is to tell it, hey, we know what we're doing. I know there are 2 sources that's impacting SPIRE external server kubeconfigs. We know what we're doing, ignore differences in those paths. Just to kind of wrap that up. All right, so we're excited about external secrets now, right? Are we excited about ESO?
Whoa, ESO.
So let's dive into ESO now. Each cluster that we manage has external secrets operator running. And yes, Mr. Gus, we are in production using external secrets. That is recorded. Each of these clusters are in their own AWS accounts. And so if you zoom in on one of the child clusters, we have a cron job that generates a short-lived kube config. Off of that, we use ESO push secret to then get it to the AWS Secret Manager's secret value. That's a mouthful. With this secret, it's a cross-account resource policy that allows the IAM role assumed by ESO and MOM to be able to read into these distinct kube config values in these distinct AWS accounts. So it's really just powered by a cross-account. There's some gotchas there and some things that are not revealed in this diagram. Number one, for all our AWS stuff, we use Terraform. So behind the scenes, what we do first is to create the AWS Secret Manager secret value with the resource policy, again, through convention. They're all named the same way, just allowing MOM to be able to read into it. The resource policy is done by Terraform. In addition, there are two important tags that we have to kind of prep it with. We call it the shell secret. The first one, compliance stuff, cost center, that type of stuff, right? That's no different than any other enterprise. The second, really important, is the tag called managed by external secrets. Anyone want to take a stab at why? Oh, Vamsing's go. It's how we trick ESO that when push secret comes along, it's going to think that I own this. So it's a way to still get your compliance, but then give the management of the actual value over to ESO. So by the time ESO push secret comes along, it's going to push it, and it's none the wiser, right? It's responsible for the value. To finish this off, you see CMK? This is going to get us to some open source goodness. The first time we tested this, support for customer managed key wasn't there. It wasn't working. Before I went to bed, I asked the question in GitHub. Overnight, a maintainer of ESO in EMEA pointed out, so it's like, it's supported, but it's not working. Maintainer in EMEA said, oh, we forgot to assign the value in initialization. Fixed it, and all we had to do is wait for the next release. So again, there's a willing and able community in both SPIRE and ESO. We just have to ask. We just have to reach out.
All right, so then let's cover Rollout. What did Rollout give us? What did we learn? And I think that these lessons will actually be super valuable to all of you. So as mentioned before, we have quite a many amount of clusters. We have over 40 to roll out to. And so that's quite a bit of possibility for consumer interruptions. So we decided with that middle tile there, why not do the passive region first? So we can first off in test learn, okay, with these really big clusters, do we have enough juice behind the RDS database? Is there any cluster specific configurations we have to watch out for that may cause SPIRE issues? And then is there any issues with our SPIRE implementation? And then the rest of the squares will be what we found out during that. So the top right one is about our shortening of our cluster names. So one thing to note is in your kube config, there is service name constraints, and that's only 15 characters. We did not realize that, so we were quite verbose. Please don't be as verbose as us. And we had to re-roll out our clusters afterwards because we had to go change their names to be shorter. And so that's a quick lesson for you to know Don't go over 15 characters. And then another one there is we use AWS. And one thing we ran into was 100 assumed role key limit with AWS. And we contacted them saying, can we go higher? And they said, nope, that's a hard limit, sorry. So then we had to go back to the drawing board and say, how can we solve this? How can we get our keys below what we need them to be? So we looked at our passive and our active, and it ended up being 3 replicas in active and 3 in passive. And so we decided, okay, we can probably lower those to 2 in active, 1 in passive. And so that helped get our 100 keys down a bit, but still not quite enough for production. So then we went back to the drawing board again, and we saw, okay, what we could do is adjust our intermediate CA time to live and make it longer. And then what that would do is make the keys not have as many in rotation. So that helped us get under that 100 key limit and then helped us continue rollout and go to production. And then one thing on this list on the top right, maybe left, I don't know. They're reversed. So was our root cluster not being highly available? And you all may be saying, Ivy, the whole point of nestedSpire was to be highly available. Yes, and that is the beauty of nestedSpire. So the cool part is workloads can validate tokens issued by the child servers without ever contacting the root cluster and the root server. So this reduces the root server dependency, and we're good there. And then another thing we decided to do was, in a failover scenario, we said, if the root cluster is already available in the passive region, then we don't really have to worry, and that's worked out so far. So we decided to put it over there. And then finally, ensuring no downtime. So you may be thinking, okay, how can we not impact our consumers in production? We've had cluster admins reach out to us saying, we don't want their applications to be impacted. We don't want their secrets to be impacted. Okay, so then this genius over here, May, she came up with the best idea ever to intentionally overlap the JWT SVID validity time of the old implementation to the new implementation. So we ended up making that 48 hours from the old implementation, and then that by then nestedSpire, as we were rolling out a cluster, it could kind of reconcile the upstream, downstream, mom could recognize it, the CSI drivers, all of that jazz. And then by then, it would be at the 48 or before the 48-hour mark, and then when that got renewed next, it would be renewed on the new implementation, and the consumers were none the wiser. But what makes them super wise is May talking about consumption.
Consumption time.
Ooh,
and
consumption.
my mic's not on. Did I turn it out?
Consumption time.
Ivy hinted on this quite a bit at the beginning. One of the great features that we were able to harvest, right, from moving to nestedSpire is the simplification of the we had many valid JOT issuers in our bespoke setup. Now it's down to just the one because mom took on that responsibility. It's still separated by the trust domain, but I kid you not, that same API that Ivy described, of course, all the other consumers, all the other apps needing their JOT SVIDs, there's one known valid JOT issuer. Next, the workload API is now available on all nodes across all node pools. Before, for valid reasons, some of these core operators, the core controllers like Ingress, Argo, including SPIRE, are scheduled just in the core nodes, including SPIRE, like I said, but with the use of the hardened chart alone. If you remember that downstream agent, that is now made available across all our nodes regardless of the node pool, making the workload API more available to the workloads that truly need their SVIDs. So +1, HA. Last one, this isn't unique to State Farm. For your applications to consume your SVIDs in a more, easier way, we of course recommend using the language-specific library. And I don't know how many times Ivy and I have been asked at State Farm, do you have exemplars? Do you have a cookbook behind this? And over, we just direct them to spiffy.io. And we never hear back. Because there's rich collateral documentation, recordings, everything that you need is already out there. But we understand in a large organization like us, there are apps that cannot be touched or cannot be refactored. Lots of reasons, right? There's always something that's constant. Time, resources, money. In those use cases, we advertise 2 exemplars. We have a cron job, and we also have a sidecar pattern. What powers it is the amazing SPIFFE helper. It's a lightweight Go app. It just works. Whether it's daemon mode or non-daemon mode, use it. You're guaranteed to get your SVID, regardless of the flavor. So use it.
All right. So
Now, where are we going?
Where are we going?
Outside of kubecrawl.
Besides kubecrawl, where are we headed? So a few things on our list. Torniak, why not have a good Spire UI? We love a UI. Another one is beefing up our exemplars and having more roadshows. So we kind of want to think of more ways to make that people may use Spire, and then just letting them know that it's out there, that they can use it. A big one is Service Mesh and X509 and Istio Secret Discovery Service, which I have homework for all of you. If any of you have used this in your companies, we would love to hear from you afterwards. So please meet us outside to talk about that, because that is very high on our list. And then finally, doing federation and introducing more trust domains, so involving more cloud providers, more data centers, doing true MTLS, connecting all of these services seamlessly. And so with that, I think we want to say thank you. Thank you so much for coming and listening to us. I hope all of this was super valuable to all of you. And now we'll take questions if you want to go to the mic over there.
Oh, you're from Geico. I remember you from yesterday. What's your question?
Hey, I was curious, do you allow anything outside of Kubernetes to use SVIDs? Do you support any non-Kube platforms?
Not yet,
Not yet, okay.
but we do. We do plan to.
Yeah.
In fact, it's on the table to even move Mom to not be just in Kubernetes.
Yeah.
Because there's no reason it can run.
Okay.
Yeah.
So I know you're driving on-prem stuff. We should chat.
I work for Geico. No,
I'll use 15 minutes.
my other.
No, that was his plug yesterday. I was at your talk, so I'm.
Okay, cool. Yeah, we can talk. My other question for you though was, for your customers, how are you managing registration entries? Are you just using the Spire controller?
Yes.
Okay.
Yes.
Cool. Great
And
job.
we have exemplars internally for when things go wrong in the database. And it's not a hard thing. We have an exemplar, and we're talking 10 tables. Yes, they're important stuff, because those are registration entries, but we have it documented.
Sweet. Thank you very much.
Thank you. And you can tell we're not experts on everything. We're very well in this journey. And our goal is to get the conversation started. I think we're fairly approachable.
I'd say so. I'd hope so. A lot of energy. So if energy scares you, that might be a deal breaker. All right. Any other questions?
Yeah, earlier in the presentation, you mentioned shortening your cluster names. Could you expand on that? What was the driver and how do you go about doing that?
Yeah, that's like a short way to describe what we did to shorten our cluster name, but we know cluster names, that's pretty invasive to shorten it, right? And we use convention. And yet we have a powerful external secrets operator where, despite the long cluster name, through advanced templating, we determine a pattern on what are the things that we can cut out. Again, ESO greatness, advanced templating, we're able to cut out some of those convention-specific stuff, but still enough to identify the uniqueness of one child cluster from another, as they all report back up to Mom.
And also to note, we didn't delete our cluster and rename it. We only did, we made some nice, a little bit of code to just take those conventions out and then push it through.
Okay, so I guess the cluster names are the same, but you just have these shorthand nicknames for them.
It's like a cute little shorthand abbreviation that we ended up putting in there.
Okay, cool. Thank you.
And that's really all to be fed into the named port. And that's an open pull request. There's still conversations going on in the SPIRE community on how we want to truly address that.
All right, awesome. Thank you.
Thank you.
Hey, well done, well done.
I don't know you.
Don't handle that. How was the adoption across your types of SPIDs? How did that go?
So we mainly did JWT from the get-go, and that was a majority of our adoption. But then later on, like I said, for the service mesh people in here, I'm looking at you, that's how we want to start combining the first usage of X509 and kind of take that as a jump point to get more X509 in there.
Thank you.
Actively cutting several exemplars for MTLS. Cross-cluster, inter-cluster, that type of stuff. And yeah, key is adoption.